Hello, so in this video I would like to explain the concept of centripetal motion. I'm going to explain where that force comes from and how can you just understand it simply without involving, too many complicated formulas. So let's just start off. So I'm going to draw a circle. Not the best circle, but it's a circle anyways. And we all know, from class, the professor and they keep explaining that the force, and the acceleration. So let me just put the acceleration, the acceleration. It goes inwards into the circle. Well, that's cool, but why exactly? Well, that's because we can simply understand like this. So at any point of the circle, let's say at this point, you're going, let's say at this point, if we just stopped this object, like froze time at this point, this object, it would have been going in this direction. So at V1. Let's say we froze this point, this object would have been going in this direction at V2. Now this is pretty intuitive, but how exactly do we understand why this gives us an acceleration inwards? Well, if you think about it, as you move on from V1 to V2, you are you're having your velocity changed inwards, and this is what I mean. So basically, I'm going to draw a separate circle, but this one's going to be a little different from the ones you're used to seeing. So let's draw like this, then like this, then another arrow, and another arrow, and another arrow, and another arrow, and another arrow. So we can see all these arrows around the circle, and basically any circle, that the object is going in, it can be envisioned as an infinite number of these arrows, around the circle. And what exactly happens? Well, every time you can see that each arrow in this case represents the velocity of the object at, let's say, certain points. So let's say a point right here, point right here, point right here, and point right here. And while it's going in this circle, the velocity is being adjusted inwards so that the object can maintain its circular motion. So what happens is that, let's say this arrow right here, you could see I'm circling around it. In order to change its direction to this arrow, we would have to change it like this. I'll draw an arrow that shows this change. So what happens, it goes like this. And then this arrow shifts inward towards the circle. So you could see if we project that direction of the shift, it would point in towards the circle. And same right here. For example, with this arrow, in order to switch it to the direction of this arrow, we would also have to change the velocity inwards. And basically this arrow would just shift this way to point in this direction. It would just be a very simple, tilt of the arrow inwards. So every time we're basically tilting the velocity inwards to move from one to the other, to the other, to the other. And when we say a change of velocity, we're talking about acceleration. So if we're tilting the velocity inwards, that means an acceleration inwards. The object is always having its velocity tilted inwards so that it can maintain this, circular motion. And anytime we accelerate, that means we're applying a force on an object if that object has a mass. Therefore, the force, which in this case we know to be mv squared over r, I'm sorry you can't see the 2, but it's there, it's going to also point inwards, just like the acceleration. And also I want people to realize is that there's no such thing as a centrifugal force. There's only one force, and that's this force pointing inwards. Because what's happening is that every time we're spinning this object, is that every time let's say this object wants to go this way up, but instead we're tilting it this way, and this way, and this way, and this way. We're accelerating it inwards so that it maintains the circular motion, so that it does not escape and just go out completely, just like, all the way, if it goes all the way out like this. We're instead preventing that by accelerating it inwards. And that's the only force that's being applied to the object. There's no magical force that's pushing it outside. It's just the rope that we tied the object to, let's say, trying to keep it inwards in this circle. So that's why we only have one force. It is mv squared over r. That's the centripetal force, and it's pointing inwards. And that is the concept of centripetal force that should be understood. Thank you for listening. I really appreciate it.